Yaodi Liu. He's head of the Global Presales Team at Trina Solar, and he had several positions in the solar industry, and he also worked even as a system engineer for ProSolia in France. And we're very happy to have Yaodi with us and talk about 600W plus ultra high power modules, core value, and integration of the industry chain. The floor is yours. Welcome.
Thank you. Thank you, Michael. Let me share my screen. Okay, hello everyone. Good morning, good afternoon, and good evening. This is Yaodi Liu with Trina Solar Global Presales Team. It's my great honor to have such a chance to talk about the whole industry chain of 600W ultra high power modules and to share 210 modules core value on system integration of PV plant to all of you. And today, my presentation consists of 3 parts. In the beginning, I will give a background introduction of 600W Photovoltaic Open Innovation Ecological Alliance and the efforts made by all participants of this alliance to provide competitive solution to PV projects. Then I'll go deeper to show you the imminent reason why 210 modules could make a saving on BOS. And in the end, I will spend a couple of minutes talking about the products we are gonna present at SNEC. In the first place, when we started research of ultra high power modules, we didn't just focus on module product itself only. We aimed to have a platform of innovation, breakthroughs, and collaborations for all participating partners and companies, covering all aspects of the whole industry chain. And that's the initial power driving us to establish the 600W Photovoltaic Open Innovation Ecological Alliance. So we kept contacting and collaborating with our partners to resolve all difficulties and problems that may come out before the wide application of high power modules to end all the insufficiencies in advance. Now, from the upstream of module manufacturing to middle stream of compatible devices like inverter and tracker, and to the downstream of application end, Trina Solar and our partners work closely together, successfully get a most cost-effective solution for PV investors eventually. This great success attracts more players in this business to join the alliance. Right now, we have 74 members in this alliance, and this number gets bigger and bigger day by day. For example, in the early beginning of this year, mainstream manufacturers of inverters such as Huawei, Sungrow, Sinon, all launched their new inverter specifically designed for 210 ultra high power modules, and also SMA, Jinlong, Growwatt, TBEA, Goodway declare their compatible solutions as well. The list is too long. I'm not going to recite the names one by one here. So that should be an end to the rumor that there's no compatible inverter for 210 modules. Tracker is another important component in system integration of power plant. Thanks to the efforts and the studies done by tracker partners in 600W Alliance, leading players of tracker like Array Technology, Game Change Solar, EDMTech, Next Tracker, PV Solar Tech, as well as Trina Tracker announced compatibility with 210 modules. Besides compatibility with equipment and devices, you might still concern about raw material and components for module manufacturing process. Like what I said in previous presentation, in our 600-watt alliance, glass manufacturers also involved in the development of pioneering 600-watt industry chain. Top manufacturers announced that on 2021, production capacity of glass will be enough to support more than 50 gigawatts of 600-watt modules, and the capacity will expand to 120 gigawatts on 2022, the next year. High current, low voltage are the unique feature of 210 high power modules. There is a key to reduce BOS of PV system. And ever since the very beginning of 210 modules development, manufacturers of junction box stay closely with us. Their high current junction box rating from 25 amps to 35 amps all have gotten certification from TUV or UL, and all are available on the market now, and their production capacity is far beyond need. And if we recall the trend of wafer size in the past 10 years, wafer size was getting bigger and bigger according to prediction of CPIA, which is China Photovoltaic Industry Association. The market sharing of 210 wafers grows fast since last 5 or 7 years, and will keep rising up rapidly in the coming 10 years. The analysis published by PV InfoLink also laterally proves that this prediction, bigger wafer will be the dominating power in this industry in the coming years. As a result of 210 wafer bloom, PV InfoLink also believes that 210 wafer-based modules will dominate the market in the next few years. Actually, that makes sense. 210 modules will be a prime preference for PV projects, because 210 modules could greatly reduce cost on BOS. In this part, we'll go to the core of BOS reduction to share why and how 210 modules make saving come true. Firstly, let's have a quick review of structure of PV plant. Certain amount of wafers go through a complicated manufacturing process, finally become a module. After calculation of string lengths, certain amount of modules interconnected in series with each other, forming a string. After parallel connection of hundreds or thousands of strings, the PV array eventually becomes a giant generator, allowing to deliver clean energy to the grid. And that's why we say that string is the elemental unit of power plant. To figure out install capacity of PV plant is easy. Just use string power multiplied by string number. The cost on cable, racks, cable tray, foundation, wiring is in direct proportion to string number. That means less the string number is, less the cost on low voltage side will be. Coming, I want to share an evolving chart of string power, module power, module number per string, and their internal connection with the change of system voltage. We can find out from the chart in the past 10 years, the system voltage was only 600 volt, gradually become 1000, Now, the most common system voltage is 1,500 for utility projects, and the PV industry is still looking for a higher voltage. Some institutes and manufacturers are working on 2,000 voltage system. But why we kept the rising system voltage continuously? Because we want to have more modules connected in one string. We want to have a higher string power, so to reduce cost on low voltage side. That's basically the consensus of industry. Higher string power, reduce BOS. As a result of system voltage increase, string power is becoming higher and higher. 10 years ago, single string power is only about 3.2 kilowatt. And this number become almost 20. 20 kilowatt. Because of the low voltage feature of 210 modules, under current 1,500 volt system, by using 210 products, we can interconnect more modules per string comparing to other products, and the string power is the highest among them all. This series also proved laterally by rated power change of single inverter and power of PV unit array. The rated power of string inverter was only 28 kilowatt for utility application a couple of years ago. And now the rated power is up to 320 kilowatt. Meanwhile, the power of PV unit array was going up as well, almost 13 times bigger than it was. Inverter manufacturers upgrade their products with the identical consensus of BOS saving in PV industry to reduce cost on low voltage side by increasing power of single generating unit. Now let's take a quick review of string calculation. According to IEC, module number multiplied by open circuit voltage of module applied with temperature correction should be lower than 1,500 volts. Based on that, so we could make a rough judgment. Low voltage modules allowed us to interconnect more modules in one string. Comparing to other modules, 210 modules could interconnect more per string, plus its module power is higher. These two positive impact make the string power of 210 is greater than that of other modules. Under -10 environmental temperature, we can make a calculation to compare 210 wafer-based 600-watt module and a 182 wafer-based 585-watt module. Due to high power and low voltage feature of 210 module, we can connect 9 more modules in one string. The string power of 210 module is higher than that of 182 modules by almost 41%. To make the point of higher string power more easy to get, we could make a metaphor. The theory of high string power is very approximate to carrying capacity of elevator. When we build a building, there are two solutions of elevators for us to choose. One is the bigger elevator with higher carrying capacity. The other one is smaller elevator with lower carrying capacity. Although the total carrying capacity of two bigger elevators is the same with 3 smaller ones, but the initial investment of 2 bigger elevators is less than that of 3 smaller ones. And maintenance work for a bigger one is almost the same with a smaller one. That's what we call cost sharing effect. And that's the same idea for BOS saving in PV industry. After all the explanations about the theory and the consensus of BOS saving in PV industry, you may clearly know our original intention and design philosophy of 210 high power modules. On one hand, we achieve the highest module power among products presenting on the market. On the other hand, we initially create a low voltage design for a module, making extremely high string power for system integration. These measures fully correspond to philosophy of BOS reduction in PV industry. Will help investors to lower down capex of PV projects and have a better IRR. With low voltage feature, we will have much higher string power that leads to minimized string number. And in terms of cost, on a low voltage side of power plant, this advantage will reduce quantity of cable tray, foundation, module number, as well as relevant installation work and wiring work. And the less string number also leads to less connection points. This connection point somehow cause energy loss. In the worst scenarios, there will be potential failure point. With less string, we will have less such kind of failure points to worry about. To be more specific about saving, comparing to 182 wafer-based 585 watt modules, 210 600 watt modules could minimize module number by 2.5%, to reduce cost on racks by 15%, and the foundation by 17%, 11 for cable, 21 for cable tray, 7 for wiring and installation. And in terms of BOS, in total, 210 module could save BOS by 0.08 yuan to 0.1 yuan comparing to 182. And comparing to 166, the gap will enlarge to 0.2 yuan. The saving on BOS means for 210 modules, we need less material to accomplish a power plant. As you might know, the price for raw material such as copper, steel, aluminum, rubber, cement rise up dramatically these days. This leads to a negative impact on investment for PV project recently. As a PV plant with 210 modules, having less need for these raw materials that allowed us have a minimal impact caused by fluctuation of the market. And in the last part, I will give a brief introduction of the products we are going to present at SNEC. Some people have a wrong judgment about 210 modules, believing that bigger wafer means bigger module. That is not true. By using half-cut or three-cut technology, we are flexible to have product with various dimensions for all installation scenarios. In 210 Vertex family, we have 40 to 50 piece products, power range from 400 watt to 500 watts, mainly focused on residential application and the SNEC segment. And also we have 550 series, 600 series, 670 series for utility scale projects, offering multiple choice for our customers to find the most suitable product for their projects. As you know, Trina Solar is not a module. It's not only a module manufacturer. We also have new and competitive solution for tracker and energy storage system. They'll be presented at SNEC as well. Firstly, I want to apologize as the confidential requirement. I can't give too much details of the contents we are going to present before opening of SNEC.
Thanks, Yaodi. We have a few minutes for questions. Maybe talking about wafers, since we have this silicon shortage these days, so how is the situation? Because you're expanding so dramatically for 210. How is the situation for wafer supply of 210 modules?
Yeah, so right now we don't have such kind of worry or concerns. We have deep cooperation with upstream supplier and signed long-term deliver contract with them. So far, our supply of wafer is stable.
Okay, that's fine. So yesterday we also learned during ITRPV's presentation that that silicon usage for bigger wafers is increasing. Can you, because of course they are somewhat thicker, can you actually reveal what's the thickness of wafers is that you are using, and what's the roadmap actually also from Trina's side? Do you have that information?
Sorry about that. I'm not so familiar with that. If I remember that right, the wafer thickness of 210 modules is between 170 to 175.
Okay. I was. It was interesting when you showed, actually, I think in one of your earlier slides, that that after 670 there could be a 700 watt module, and you showed a system voltage of 2 kilowatt actually. So I think, so first of all, the question is, when do you think we will see modules as big as 700 watts, and what's the implication for 2 kilowatt system voltage? Because I think there were it took quite a while also when we went to 1.5 kilowatt, because of safety concerns and whatever. So I think can you just comment on this?
Yeah, it's just how to say, it's a prediction for the future. We always say that there's a will, there's a way, and for module, I believe there's a module, there's a solution. The only thing matters is how much this solution is going to cost. As I said in my presentation, we've cracked all possible difficulties in advance. So far, I believe the 210 modules with 670 watt modules is the best solution for the application. But in the future, if we can figure out how to make transportation, how to make efficient installation, I believe there is a chance for a bigger module.
Okay, great. So I think so since we learned from many companies also that they are now looking into into next generation cells, because the module I don't know, it's the module development opportunities or the potential for further optimization is closely coming to an end with PERC cells. Trina has been working on a couple of technologies so far. You said you cannot say so much about SNEC, but is there an N-type product you might wanna or you will have on display at SNEC, or is this too early to say?
I can tell. Let's just wait for a couple of weeks, 2 weeks. You will see all the secrets and all the information you're interested in at SNEC. So far, okay. I can't tell you more about it.
Okay. Okay. I think here was one question actually in the chat. What kind of what's the size or what of the purlins you use in trackers for the big modules? The question was, do you use 400mm purlins, or do you know that actually? What
about that, calculation of structure of tracker is complicated. We cannot use the same plane, a dimensional plane for all the locations. Sure. That kind of thing need to be studied case by case.
Okay. Okay, but the tendency, so for the larger modules, if you compare your tracker now, we also published recently a tracker survey in which Trina is covered, but here just for the conference, if you compare the new modules with your smaller modules, so how have the purlins changed?
Actually, both smaller modules and bigger modules go well with trackers, or let's just say Trina trackers. The only difference is the cost efficiency. With higher modules, we can reduce the cost per watt for the whole system.
Okay, thanks. I think that's it from my side. Yaodi, thanks so much for this interesting presentation. And have a nice evening.
Thank you. Thank you, Michael.
Bye-bye.
Bye.